Good morning, everyone, and I hope that the guys who have made it onto campus today have enjoyed the process. I can't wait to be there myself later today to see all of you, and I hope all of you who are working from home are also just as excited to get back. Our next topic is financial mathematics for grade 12. However, we're going to extend some of the grade 11 concepts first, and what we will be doing is tying together pieces from sequences and series, functions, and logs, everything that you've done recently with us. So hopefully this all starts to make sense. We're not going to rush through this section at all. And at the end of it, I think you'll be quite comfortable in knowing what types of questions will be asked for the 15 marks that finance is worth in paper 1. Before we begin the lesson, I think you should get yourselves a pen or pencil, a notepad, a calculator, and maybe go to maths.studian.com and get the formula sheet. I've got a small example of it here on the screen. You don't need the silver calculator, you just definitely need a calculator that can work, that has a log button. So go get those things now, pause the video, and then come back. Okay, so let's do some revision of grade 10 and 11 finance, and you will recognize these formulas, perhaps not all the variables, but their position is the same. We have the simple interest formula, which is looking at what happens if you take an amount and it has interest and time inside the bracket, and it accumulates to some normal simple interest amounts afterwards. We've got compound interest, which takes a value, and then interest and time work as exponents to each other. We have simple depreciation, which I think it's important that you know can be described by its other name, which is straight line depreciation. So I'm going to put that in here in case you see this in a question. This is straight line depreciation. And that is just the negative version of simple growth. We have compound depreciation, which is the negative version of compound interest. For those of you who do accountancy, you will probably recognize this name as the reducing balance form of depreciation. So get used to seeing both of these names. Straight line and reducing balance could be asked in a question, but all they're asking you to do is either work out simple interest or compound interest. The formula that we added in grade 11 was to look at the effective annual interest rate, and that was when we found that you could have multiple compoundings and multiple divisions of the interest rate that you were quoted. We will not be adding any new formulas today. What we'll be doing is working with these that you've seen already and manipulating them so that you feel comfortable going into any of the assessments that are coming up. So let's start with simple interest. How could we calculate the period of a simple investment? If you can picture the simple interest formula, which was A is equal to P 1 plus I n, pause the video for a second and try solve for n. Hopefully you did the following. We want to break the bond between P and the bracket, so we will first divide by P, and we're left with 1 plus I n. And then what we'll do is we're going to adjust this a little bit so that it looks a little neater. I'm going to bring I and n on this side, and what I will have is A over P minus 1. Hope you don't mind what I've done there. And then to solve for n, we divide both sides by the I. So n is equal to A over P minus 1. That entire fraction is divided by I. Sorry, my eyes look strange, but that's just the easiest way I can write them on my iPad. And this is how we would be able to describe how long it takes for a simple investment to grow. You never need this formula, it's not on the formula sheet, but you could quite easily, I believe, get yourselves from this point to this point by doing some basic algebra. I have a real sense that some of you are going to hate the shortcut I took, so let me take this one over here and perhaps rewrite it so that you feel a little bit more comfortable. I'll write it just on the side. If you took the 1 over, you would have A over P minus 1 is equal to In, and if we divided both sides by I, you would have A over P minus 1, all in brackets, divided by I, which is equal to n. It's the same as what I wrote on the left-hand side, so hopefully you feel okay with that. Now, what about solving for a time with a compound interest? Compound interest, as you would have remembered, is A equals P, brackets, 1 plus I to the n. Pause the video for a second and try solve for n using logarithms. I hope you've tried it. Let's follow some steps. Firstly, let's divide by P again. So we have A over P is equal to a base raised to some power. And you've seen this before. This is in exponential form. If I wanted to detach the power from its base, I would take the log on both sides. I would say that the log of this side and the log of that side could be determined. And you know that in the log world, we don't like to have powers. So I would have log of a over p. The power n would come down as a coefficient, and I would still have the log of the interest rate component. We're quite happy now because all we will have to do is break this bond over here of multiplication. And so I could rewrite it as log of a over p divided by log of 1 plus I is equal to n. And for those of you who remember some of your log reductions, you'll recognize the following. So I'm just going to write this and we'll flatten it in a second. So I've turned it around. Here's our a over p. Here's our log of our interest rate. And what you would recognize, I hope, is that n could be described as the log of the base and the subject. And this is really useful for us now because we are now able, for the first time, to isolate a power inside a financial question. In grade 10 and 11, if they asked you to solve for n, you had to do a whole lot of test values before you could get to it. Now we can immediately convert into our log form and solve for the power of an investment. The next 8 questions are all going to be on this. I will do 2 examples, and then you're going to do 8 yourself, and I'll do a worked example of each of them for you. Example 1, determining the value of n. Question, Tembile invests 3,500 into a savings account which pays 7.5% per annum compounded yearly. After an unknown period of time, his account is worth 4,044 Rand and 69 cents. How long did he invest? First thing, let's write down the formula we're going to be working with. We know that this is a compound formula. It tells us this in the question, so compound formula. And so what we will do is use the compound formula for investments, 1 plus I to the n. Let us write down the numbers that we do also know. We know that his accumulated amount was 4,044 Rand and 69 cents. We know that he invested a present value of 3,500, and we know that the interest rate was 0.075. For those of you who don't remember how to do that, it was 7.5%, and I've just divided 7.5% by 100 to get 0.075. So let us take the equation and manipulate it. We know that A equals P, 1 plus I to the n. I know that 4,044 Rand and 69 cents came from 3,500 Rand invested at 1 plus 0.075 to the n, the unknown power. I'm going to now rewrite this and try solve for n in a few steps. First things we do is we divide through by the present value. So you'll have 4044.69 divided by 3,500 is equal to, I'm going to combine the numbers in the brackets as 1,075 to the power of n. What we're now allowed to do, for those of you who've seen this and have done quite a lot of this practice, we can convert from exponential form into log form. And that step says the following. It says what we're allowed to do is take the power that we're interested in, and we're going to take the logarithm of a base, which was the base that you saw here, 1,075, and the subject will be the quotient of the future value and the present value. And on your calculator, you would find the log button. On the calculator, the button you're looking for, I think, depending on your calculator, it looks like that. You'll plug in the values that you see, and what you'll get out is 2,00 ... So what we can say is it took 2 years. Let's look at a second example. Margot has 12,000 Rand to invest and needs the money to grow at least 30,000 to pay for her daughter's studies. If it's invested at a compound interest rate of 9% per annum, how long must the money be invested? Let us put down what we know. We know that we're dealing with compound interest, so we know we're dealing with this formula. We know how much she wants to invest, and the investment amount and the accumulated amounts are given in the question. She wants to accumulate 30,000 Rand, and we know that she started with 12,000 Rand. We know that her interest rate is 9%, and I'm going to write that out in decimal form. What we want to do then is manipulate this formula to solve for how long it's going to take. So what we can say is that we have 30,000 Rand that has grown from 12,000 Rand at an interest rate of 9%, and we want to work out n. First things first, I'm going to divide 30,000 by 12,000. 30,000 divided by 12,000 is a multiple, so I'm just going to write it as its own fraction, 5 over 2. In the brackets, we've got 1,09, and we've got power n. Again, what we will do is convert from exponential form to log form. The subject I want is n. It comes from the log of the interest rate component and the fraction or the quotient that is the future value divided by the present value. And so what we find if we plug this into our calculator is we get 10,632 years. How do we interpret this? It's important to note that the number in front of the comma is a year, and the number after the comma is parts of a year. So it is 63% of a year. Don't worry about converting these. I think it's best if we read the question and it says, how long in full years will her money need to be invested? Well, it needs to be longer than 10 years. It's 10 and a bit years. So therefore, what we will say is she would need 11 years of investment. We now begin the 8 questions that you're going to try yourself. So you will be probably asked, and I'll try pause these and then I will do solutions for you. Question 1. Nzuzo invests 80,000 Rand at an interest rate of 7.5% per annum compounded yearly. How long will it take for his investment to grow to 100,000? Pause the video and try the question yourself. All right, good. So you've probably done the following on your notepad. You've written down that we're dealing with compound interest. You've written down that you know that the accumulated amount must be 100,000. That we started with 80,000. And that our interest rate is 7.5%, so 0.075. Let's set up the equation over here that we're going to solve. A equals P, 1 plus I to the n. We'll put in the values, 100,000 equals 80,000 equals 1 plus 0.075 to the power of n. If I take 100,000 and I divide it by 80,000, I'm left with a fraction of 5 over 4. In the brackets, I would have 1,075 to the power of n. And I'm going to convert it from exponential form into its log base form. So we get log of the interest component, oopsie-daisy, 175, and the quotient of the future value divided by the present value. And we put that into our calculator, and we find that n is 3,09 years. The question says how long? Just over, so we could say this is just over 3 years. Okay, question 2 for you to solve. Sally invests 120,000 Rand at an interest rate of 12% per annum, compounded quarterly. I think it's important that I highlight that, compounded quarterly. How long will it take for her investment to double? Give this question a try and watch me for the solution. Well, let's put down what we know. We know we've got compound interest, so we're using this formula. A equals P, 1 plus I to the n. We also know that her accumulated amount needs to double, and it's double the original amount. Well, the original amount was 120,000, so the accumulated amount is 240,000. The interest rate, importantly, we want to write out in its full form, and the interest rate is 12% quarterly. So we will say 12% divided by 4. And we can work that out on our calculators later. When we want to solve for n, we would say that A equals P, 1 plus I to the n. We know we want to make 240,000 from 120,000. And that must come from 1 plus. I'm going to convert these now as a 12. Instead of percents, I'm going to write the 100 times the 4, which is the quarters. And it's important now to match my power of variable to the inside interest rate. So if I divide by 4, I've got to multiply this by 4 because now we're dealing in quarters, not just whole years anymore. What we will then do is say 240,000 divided by 120,000 equals 2, and that tells us the money has doubled. Within our brackets, you're going to do a calculation on your calculator, and it works out quite neatly to 1,03, and the power is still 4n. We can now convert from exponential form into log form, and we know that 4n must have come from log of the interest component and the quotient of future value divided by present value. That tells us that 4n is equal to 23.449. I still need to divide by n on both sides. Divide by 4 on both sides, which means in year terms, these are in quarters. Let's just make a note to ourselves. This is still in quarters. If I took 23.449 and I divided it by 4, I get 5,86 and a bit years. The question says, how long will it take for the money to double? What we know is it'll take 5 years. Those of you who want to work out this decimal component, you could also say, what is 0.86 times 12? So 0.86 times 12. If you've done this on your calculator, 0.86 times 12 is equal to 10. So really we could even refine our answer down to 5 years and 10 months if we wanted to. They haven't really asked us for that, but that's just how you would do it. Okay, question 3. When Banelli was still in high school, he deposited 2,250 Rand into a savings account with an interest rate of 6.99% per annum compounded yearly. How long ago did Banelli open the account if the balance is now 2,882 and 53 cents? Write your answer as a combination of years and months. So let's just keep a note for ourselves that they want this to be in years and months. Pause the video and try this question yourself. Okay, as with all good memory muscle, we have repetition of practice. We write down that we got compound interest. We want to isolate the variables that we do know, so we know that they want to accumulate 2882.53. We wanted to accumulate that from 2250, and the interest rate that we were told is annual at 6.99%, so 0.0699. For us to solve for how long in years and months, we will take our formula, A equals P, 1 plus I to the n. Let us put in our 2882.53, which came from 2250, 1 plus 0,0699 to the power of n. First things first, let's divide 2882.53 by 2250. In our bracket, we're going to have 1,0699 to the power of n. We will convert exponential form into log form. So n is equal to the log of the interest rate component and the quotient of the future value over the present value. In our calculators, we would type this in, and we find that n comes to 3,6 recurring. Well, we need to convert this. So importantly, let's make a note here. We know that we've got 3 years, but we want to rewrite the 0.66 recurring into months. So we would take 0.66 and convert it into months. So again, I'm just going to make a small note. We're going to say, let's take 0.6 recurring, which is about 0.67. Let's take 0.67, multiply it by 12 to give us our months. And what we find is that 0.67 times 12 works out to 8 months. So therefore, Banelli did this 3 years and 8 months ago. Okay, question 4. An annual rate of depreciation, so this is the first time now we're dealing with depreciation, of a vehicle is 15%. A new vehicle costs 122,000. After how many years will the vehicle be worth less than 40,000? Pause this video and give it a try yourself. Let's set up the equation. We know that we're dealing with depreciation and we're dealing with compound depreciation, so we're dealing with this formula, the negative inside the bracket. We know that our accumulated amounts must be less than 40,000, so let's make 40,000 what we want to aim at. We know we started with 122,000, and we know that our interest rate was 15%. For us to solve for n in this equation, p is 1 minus I to the n, let's put in the values. 40,000 came from 122,000, and the interest rate was 0.15 to the power of n. Let's take 40,000 and divide it by 122,000, and what we find is we get a fraction of 20 over 61. And when we say 1 minus 0.15, what we get in the brackets is 0.85 to the power of n. We want to convert exponential form into log form, so n is equal to the log of the interest rate component and the quotient of the future value over the present value, which tells us that n is equal to 6,86, and this is in years. So therefore, what we're looking at is that it needs to exceed this value. We want to go less than 40,000. So the first year that is after 6.86 years is therefore 7 years. That's the answer. Okay, question 5 for you to work on. Some time ago, a man opened a savings account at a South Bank and deposited an amount of 2,100. The balance in his account now is 3,160 Rand and 59 cents. If the account gets 8.52% interest per annum, how many years ago was the deposit made? Pause this video and give it a try yourself. Okay, this seems reasonably straightforward. Let's set up what we know. We know that we've got future value of an investment. So we have this formula. We know that the accumulated amount is 3,160 Rand and 59 cents. We know we started with 2,100 Rand. And we know that our interest rate on this section is 0.0852. A bit of a messy interest rate, but let's work with it. We know that we're dealing with this, so we can start to set up our solution. And what we want to solve for is n, how long. Let's invest 2,100 Rand and make 59, there we go, so 2100, and it's 1 plus 0,0852, it's the power of n. We divide both sides by 2,100 and we're left with 3160.59 over 2,100. Must have come from 1,0852 to the power of n. We're going to convert that from exponential form into log form. N is equal to log of the interest rate component and the quotient between future value and present value. A lot of you are going to start to ask, perhaps, can we just skip some steps? I'm very happy if you're comfortable. I just know that I want to make sure that you get all the marks you can, so showing all the steps is just a really good way to make sure small mistakes don't happen. If we plug this into our calculator, what we will get is this works out to 4.999 recurring. So it is about 5 years ago that this would have happened. So 5 years is the answer. Okay, question 6. Mr. and Mrs. Lamini want to save money for their son's university fees. They deposit 7,000 Rand into a savings account with a fixed interest rate of 6.5% compounded annually. How long will it take for the money to double? Pause this video and give it a try yourself. I'm going to do this video, but I'm going to just extend the thinking a bit about this understanding of what it means when the money doubles in value. If a certain amount of money doubles, do we need to know what we started with? And what I mean by that is the following. If we know that this formula, A equals P, 1 plus I to the n is the standard formula, and we have some interest, some amount that we put in, an unknown amount. If you're happy with the following, if you know that the money is going to double, that means that the accumulated amount must be 2x. And we would still have our interest rate, of some interest rate. In this case, the interest rate is 6.5%, so 0.065. For now, I'm not going to use their 7,000 Rand, because hopefully you can see that if I plugged in 7,000 Rand here, the doubling of 7,000 Rand would be 14,000. However, any amounts plugged in and doubled would just lead us to have double the original amount. So by that I mean the following. If we know that a certain amount of money is going to double, let's just do this. If I know that this is going to double when it becomes that, then all I need to do is write the following. 2 equals 1 plus I to the n. Some of you are going to be unhappy with that, so I'm going to erase it for a second, and I'm going to put in the other numbers, the 7,000 and the 14,000, which we were given in the question, and you'll see we'll still land up on the 2. So let me just erase those, and let's put in the numbers we were given. We were told that we made 14,000, we doubled 7,000 when we invested at this interest rate, 0.065. If you say 14,000 divided by 7,000, we get 2, 1,065. So this is a shortcut for you. If they ever say that money doubles or triples or halves, we don't necessarily need to work with the original amounts. We can quite easily jump into this line where we're working with the output of that fraction. Anyway, let's convert our exponential form as it stands right now into log form. N is equal to the log of the interest rate component and the quotient of future value divided by present value. And in this case, the money takes 11 years. I think it's 11 and a bit on your calculator, so I'm going to write those in ... But basically, it is 11 years for this money to double. Question 7 is a two-part question, and they both relate to the original information. A university lecturer retires at the age of 60. She has 300,000 Rand over the years she's saved, and she decides to not let her savings decrease at a rate faster than 15% per year. How old will she be when the value of her savings is less than 50,000? Pause this video and give the question a try. Okay, so we need to know which formula we're using. Well, money is decreasing here, so we know that it's decreasing at a compound rate. So we're dealing with this interest rate formula. Oops, not R, interest rate. We know that she wants to not have less than 50,000 at the end, and we know that she started with 300,000 at the beginning, and we know that the interest rate is 15%. So what we're going to do is solve this equation, 1 minus I to the n. We want to have the accumulated amounts being 50,000 from 300,000 at a rate of 0.15 to the n. Well, 50,000 divided by 300,000 is 1 over 6. And 1 minus 0.15 is 0.85. We have exponential form here. And so what we want to do is convert it to log form. N will be equal to the log of the interest rate component. Oops, that's supposed to be an 8. Sorry. 8.5. And the quotient of future divided by present. And what we find is that you get 11.024. Now the question isn't fully answered because they say to us, at what age will she be? Well, if she's 60 now, and it's going to take 11 years to reduce, she will be 71 years old. Question 7b relates to the first part. If this retired lecturer doesn't want to use her savings and invests all her money in an investment account that earns a fixed interest rate of 5.95% per annum, how long will it take for her investment to grow to 390,000? Pause this video and give it a try yourself. Okay, so in this one, we need to figure out what is happening. Is money growing or is money reducing? We're investing money here, which means we're dealing with A equals P 1 plus I to the n. We know that she wants to accumulate 390,000, and we know that she invested the 300,000 Rand from her retirement. Oops. And now the interest rate is 0.0595. So we're going to solve this equation. 1 plus I to the n. Let's put in what we know. We want 390,000 coming from 300,000 at an interest rate of 0.0595 to the n. 390,000 divided by 300,000 leaves us with 1,3. And inside the brackets, we've got 1,0595 to the power of n. If I convert from exponential form into log form, n is equal to the log of the interest rate component and the quotient of the future value divided by the present value. So n is equal to 4.539. So about 5 years is how long it would take for her money to grow. Okay, and your last solving for n question for today. Simositu puts 450 Rand into a bank account at the Bank of Uppington. The account pays an interest rate of 7.11% compounded monthly. Let's make a note of this because the monthly is important. After how many years, okay, so they're giving us two different time zones, will the bank have accumulated 619 Rand and 9 cents? Pause this video and give it a try yourself. Okay, let's set this all up. Is the money growing? Yes, it is. So we know we're dealing with this formula. We know what we want to accumulate, and we want to accumulate 619 Rand and 9 cents. We wanted to put in 450 Rand. And we know that the interest rate quoted to us is 0.0711, and that's per annum. So for us to work with our rate, which is in months, we know we're going to have to divide by 12 in our formula. So keep that in the back of your mind. In our formula, if we've got A equals P 1 plus I over M, because now we're dividing by a new number, a monthly, we would have to multiply our powers by M. So this is just to make sure that our interest rate and our time zones are in the same. If we fill this in, we're going to say that 619.09 came from 450, 1 plus 0.0711 over 12, and our power is going to be 12 times n. So nothing too complicated there. Now what we want to do is take 619 Rand and 9 cents and divide it by 450. So 619.09 divided by 450 is equal to, in our brackets, we're going to get quite a messy number. And this is one of the first times I'm going to say to you, keep these messy numbers on your calculator. Do not concatenate, do not drop things. Keep them and write them as much as you can, and store them in your memories of your calculator, because it's going to be important. Every single time you hack off one of these decimals, you lose money. So keep this number. And when I say this number, I mean this number. Keep this number inside your calculator somewhere. Store it, because it's important that you use the whole value. What's going to happen now is we're going to convert from exponential form. Oops, I left out an n. We're going to convert from exponential form to log form. So we know that 12n is equal to log of this whole long number, which you should have stored somewhere in your calculator, and then the quotient, which is 61909 over 450. And what we get when we solve this on the right hand side is 54, but we have to be careful and remind yourself that this is 54 months, because we still have the 12. If I take 54 months and I divide it by 12, 54 divided by 12 means that n equals 4,5. And now we are in years. And the question asks us how many years. So it's going to be 4.5 years. 4.5 years for this money to do what it needs to do. I hope that you've understood and enjoyed these questions on solving for n. Coming up next for you, those of you who want to read ahead, is the idea of annuities. Spelling looks bad today. Is the concept of annuities. And annuities for us will draw in concepts that you would have seen from logarithms. It'll draw in concepts that you would have seen from the original finance you did today and in past grades, as well as draw in concepts from sequences and series. And so it really starts to tie together a whole lot of the aspects that you want to be able to manipulate. You do need to have quite a strong sense of dealing with this, which is why I was so kind of making a point of today to do 8 of the same types of questions to solve for n. So I really hope that you've enjoyed this video. If you need more practice, please contact me or your teacher. Have a good one.